Alright, so this is the System of Equations unit review packet. Today is test day, so this is a great chance just to go over kind of everything briefly before you take the test. Start off with just real basic. System of equations means we're going to be looking at more than one equations that are using the same variables, usually going to be x and y, and we're going to be focusing on solving systems of equations by graphing, substitution, and elimination. Then we're going to take a quick look at word problems, and that pretty much covers it. So these first ones, we have two that we're going to solve by graphing. And when we're solving by graphing, this means we're going to be looking for an intersection point. So the best way to go about this is to just graph both of the equations, look for where they intersect. So in this first one, we have y equals 3x plus 4. So our slope is 3, our y-intercept is 4, so we can plot that y-intercept. And then a slope of 3 means we're going to go up 3 and right 1. Now you can see here we can't really go up 3 and right 1 because that'll take us off our graph. So it's going to go some direction that way, but we can go backwards. So if we're going up 3 and right 1, we can work backwards and go down 3 and left 1. And then keep doing that to draw this first line. So this is the equation y equals 3x plus 4. Now we have to graph the second one. So we have y equals negative 4x minus 3. We're going to do the same thing, plot the y-intercept. Make sure you're careful. This is a intercept of negative 3, so plot that. And then the slope is negative 4, telling us we're going to go down 4 and right 1. But we have the same problem here. We can't go down 4 and right 1. That would take us off our graph, but it's going to be going some direction this way. But just like here, we can work backwards. So if we were going down 4 and right 1, we would need to go up 4 and left 1, up 4 and left 1 to work backwards. So then we can connect all the points. And so this is our equation y equals negative 4x minus 3. Now we're looking for the solution, and that's the intersection point that we see right here. So we can determine that the solution is negative 1, 1. So when you're solving systems by graphing, the best thing to do is just plot the y-intercept, use the slope to graph the rest of your line, and when you have both lines graphed, identify the intersection point. A big piece here to recognize is that these have different slopes. This is a slope of 3, this is a slope of negative 4, meaning that they're going to have one solution. Whenever two equations have a different slope, it's going to have one solution. Now you can check your answer here for the second one. So this is both systems already graphed. We did the same process here, but we can see that these equations have the same slope. Both of them have a slope of negative 3 over 2, but they have different y-intercepts. The first one has a y-intercept of negative 1. The second one has a y-intercept of positive 1. And because they have the same slope, but a different y-intercept, that means they're going to have no solution. They're going to have no solution, meaning they're never going to intersect, and there's never going to be an xy pair that satisfy both equations. So this pretty much covers graphing. It's a pretty useful method because you can, kind of see what's going on. But we're a little limited with graphing because it only is helpful when we have integer solutions. So we can clearly see that the solution here is negative 1, 1. But if we ever get a solution that's not integers, it's not all that helpful. So that's a good segue into our next method, or our next strategy, substitution. So we're going to do both of these just to make sure that we kind of have all of substitution covered. So this system is x equals -3, and then x minus y equals -4. Now, because we have x isolated already, that means anywhere in the second equation where you see an x, you can substitute -3, or you can replace this x with -3. So that means I can rewrite this equation as -3 minus y equals -4. Again, all we did here was we substituted -3 for x. The only thing changing is x. Now I can use my inverse operations to solve for y. So I'll add 3 to both sides. So we're left with -y equals -1. Now we're almost done, but be careful, the coefficient here in front of the y is a -1. So I'm going to divide both sides by -1. We get y equals +1. Now a reminder, when we're solving system of equations, we always want our final answer to be a coordinate point. Now we have the y value, but if we look back up at the equation, we already were given that x equals -3. So I can use both of these to write our coordinate as -3, 1. Now we can check our work taking the second equation, x minus y equals -4, and substitute our values into the equation. So we would get -3 minus 1 equals -4. We get -4 equals -4. So now we've done a pretty basic level substitution problem. We're going to do one more. This one's a little bit more challenging because we have y isolated, but it's equal to -3x minus 6, rather than in this first problem where we had x equal to the number -3. But we're going to still apply the same concept. Instead of y in this equation, we're able to substitute -3x minus 6. So we can rewrite this top equation as -5x plus 2 times -3x minus 6 equals 32. Now, before we can solve, we're just going to clean this up a little bit using the distributive property. So we can distribute this +2 inside the parentheses and rewrite this whole equation as -5x minus 6x minus 12 equals 32. Now we can combine like terms. -11x minus 12 equals 32. Now we have a two-step equation. We can add 12 to both sides. We get -11x equals 44. And if we divide both sides by -11, we get x equals -4. So now we have the value for x, and we're going to take one of these top equations to try and solve for y. Now, because the second equation, y is already isolated, that one's going to be a little bit more efficient, but either equation would work. So if we rewrite this bottom equation, y equals -3x minus 6, but we already have the value of x, so I can substitute that in here to rewrite this as y equals -3 times -4 minus 6. So we would get y equals 12 minus 6, giving us y equals 6. So now we have x and we have y. We can rewrite this, or we can write our final answer as a coordinate point, -4, 6. Now, if this were a test or really any other problem, you're going to substitute these in to both equations to check your work, but just for time's sake, we're going to move on to the next problem. So if you turn your page, there is one more system of equations to solve using substitution. That is right here. So right now, if you want to check your work, pause the video. You can go through everything that I did. My solution is 1, -1, and I checked it over here. Alright, so we're going to move on from substitution to elimination. So we've done graphing, we've done substitution, and now we're going to do two problems using elimination. So this top equation, we want to solve the system of equations using elimination. That means we're going to add or subtract the whole equations together to try and get rid of one of the variables. So if we look at this equation, x minus y equals 11 and 2x plus y equals 19. I want us to think about if we added or subtracted these equations together, which variable could we get rid of? So really we want to be looking at the coefficients. And you'll notice that this y has a coefficient of -1, and this y has a coefficient of +1. So we have a -1, we have a +1. We want them to equal 0, meaning that our operation is going to need to be addition. So we're going to add these two equations together, and we're just going to add down each column. So this is really important, though, that all of the same variables are lined up. So we have the x's in this first column, we have the y's in the second column, and then on the other side of the equal sign, we just have our constants. So in this first column, we have x plus 2x giving us 3x. This middle column, this is what we're eliminating, so this gives us 0. So I'm just going to leave that blank because +0 doesn't change anything. And then on the right side of the equal signs, 11 plus 19 gives us +30. Now the reason this is so efficient is because now we have a one-step equation. We can divide both sides of the equation by 3 to solve for x, giving us x equals +10. So now we already have one of the variables, and we can use what we know about substitution to find the other. So it doesn't matter which equation we use. I'm going to take this bottom one, 2x plus y equals 19. I'm going to substitute 10 in for x. So we get 2 times 10 plus y equals 19. Now we can just evaluate 20 plus y equals 19, and then subtract 20 from both sides, giving us y equals -1. Now again, we always want our final answer to be written as a coordinate point. So we can take both of these and write our coordinate as 10, -1. Now I want you to pause the video and check my work. So off to the side here, go through, substitute this into both equations, and make sure that our answer is correct. Alright, so if you checked your work, it should look something like this. We substituted 10 for x and -1 for y, so it does work. Our solution again is 10, -1. And then there's one more elimination problem. This one was used subtraction. So when we subtracted, we were able to eliminate the y's. Again, feel free to pause the video right here, go through the steps, how I solved for x, substituted back in to solve for y, rewrote the final answer here, and then checked our work off to the side. Alright, so on this next page, it's asking you to describe the steps for how to solve this system of equations. We're not going to go through this because we did it as our do now last Friday. We've also done 2 elimination and 2 substitution problems, so I'm sure you can go back, watch how we did them. If you need help getting set up, the best thing to do is just put a line down the middle, just actually solve the equation on the right, and then as you're solving, list your steps on the left. But this is one that we solved on the last page, so I'm sure you can go back, go through the steps, and list how you solved it. So the last thing we're going to do is on the very back page, go through a one-word problem. The biggest piece here is making sure that we're defining our variables and writing the correct equation, because if we don't do that, then it doesn't really matter what you do from there. Your answer is not going to be correct. So if we look at this word problem, we have Casey wants to buy a gym membership. We have one gym has a $150 joining fee and costs $35 per month. Another gym has no joining fee but costs $60 per month. In how many months will both gym memberships cost the same? So we want to know where they are equal. Now, first we're going to define our variables. So I see that we have, we're measuring money here, and it looks like it's increasing every month. So if we were to write an equation as y equals mx plus b, and we were to think about the independent variable and the dependent variable, I know that the number of months is going to determine the total cost. So that means that our x is going to be the number of months, and the y is going to be the total cost of this gym membership. Now, in the first gym, that has a $150 joining fee, and this is just a one-time fee or a starting cost. So this is going to be our b value. So b equals 150. And then this $35 per month. The per month tells us that our slope, or our m value, is going to be 35. So we can take our m and b values and write the equation for gym 1 as y equals 35x plus 150. And now gym 2 has no joining fee, so that means the y-intercept is going to equal 0. But this $60 per month tells us that the slope, or the rate of change, is going to equal $60. So we can write that equation as y equals 60x plus 0, or y equals 60x. Now we want to know where they are equal. We want to know where these graphs would intersect if we were to graph them. Just because we don't have a coordinate plane, and also because we're using some pretty large numbers here, we're going to use substitution. Now, this is even though this is a word problem, this is a system of equations because we have more than one equation, and in both equations we're using the same variable. We're using x and we're using y. So we have y is equal to 60. So I'm going to take this, or excuse me, 60x. I'm going to take 60x, I'm going to substitute in for y into the first equation. So this first equation can be rewritten as 60x equals 35x plus 150. Now we can solve for x by subtracting 35x from both sides, giving us 25x equals 150. Now, if we were to divide both sides by 25, we get x equals 6. So if we look back up at the question, we're being asked in how many months will both gym memberships cost the same. We said x is our number of months, so we are all done. We know that after 6 months, the gyms cost the same. Now, just to double check, let's just figure out how much these are going to cost. So we could substitute this x into either equation. I think it's going to be easier in the bottom one. So if we were to write this as y equals 60x and substitute 6 for x, we get y equals 60 times 6, or y equals 360. And now again, y is our total cost, so this means that after 6 months, both gyms will cost $360. Alright, so this very last problem, this one was a little bit trickier, asking us to define some variables here. So this problem says, Mr. Burrows only has dimes and quarters. He has a total value of $5.80, and he has a total of 40 coins. In this section right here, we're being asked which of the following systems could be used to find the number of dimes, D, and the number of quarters, Q, that Mr. Burroughs has. So it looks like we're going to use the variable D for dimes, Q for quarters, makes sense. And we're going to have two equations. We're going to have a cost equation, looking at the total money that he has, or that I have, and then we're going to be looking at the quantity equation. Now, cost equations and quantity equations are really popular in business and in any high school math that you do, just because it's really easy to apply to real life situations. So if we think about this quantity equation, he's going to have a certain number, I'll do this down here, a certain number of dimes, D, plus a certain number of quarters. And then if we look up here, it says he has a total of 40 coins. So the number of dimes added to the number of quarters is going to equal 40. Now with this in mind, I can see we can already eliminate this first system and this third system. So we're looking between these two. Now if we were to think about the cost equation, or the total money that he has, he has a certain number of dimes, he has a certain number of quarters, he has $5.80 total. But now we need to think about the value of each of these. So a dime is worth 10 cents. So for every dime, we can multiply that by 0.10, or 1/10 of a dollar, and then added to 0.25, or 25 cents for each quarter. So this tells us that for each dime, we have 10 cents, plus 25 cents for each quarter, and if we added this up, we're going to have a total of $5.80. So with this equation and this equation, we can see that this looks very similar, actually identical, to choice D. So this is our choice for the correct system of equations. Now, go back through the packet. This pretty much covers the majority of what we've learned this unit. Just make sure that you are really solid using graphing, substitution, and elimination, and make sure that you're able to really explain what it means for something to be a solution to system of equations. Besides that, be confident. Y'all got this.